In today's note, we are going to be looking at solving equations. So basically, when we say we want to solve an equation, what we're doing is that we're trying to find a value for the variable or the letter in the equation. And there's different ways to think about solving an equation, but the method I've talked about, or the method I'm going to talk about, is you have to think about applying opposite operations. Because again, the main idea is we want to get the variable by itself or we want to isolate it by itself. And in order to do that, we need to get rid of everything that's around it. And how we do that, or how we think about doing that, is opposite operations. So the idea is taking the order of operations that we know of BEDMAS and doing the opposite. So that goes for the order as well. So subtraction and addition, multiplication or division, exponents, and then brackets. Right? So we're going in the opposite order. Notice how with the brackets, it's a lowercase b. That's because we're going to do something slightly different with brackets, and we're going to talk about that in a future note. Some of the steps you want to think about is first, determine the variable that you are solving for. So you want to think about what variable am I solving for, or what letter is there that I'm trying to find a value for. Any terms that are being added or subtracted to the variable should be looked at first. And again, that's because if I look at my reverse BEDMAS or opposite operations, subtraction and addition is first. Next, do the opposite operation to clear the term from the side of the equation with the variable. And again, I'll walk through that in an example. And when we do that, we have to do it to the other side of the equation as well. So think of it as a balance beam, right? What you do to one side, you do to the other. Because if you only do something to one side, then you're changing it. You're shifting the balance, and it's not going to be the same as what it was. After we do that, next we move on to multiplying or dividing, because again, that's the second thing when we do the opposite operations. So I'm going to look at a couple of examples. So if I look at my first example here, x plus 7 equals 39. So the variable that I want to solve for is this x. Right? I want to get x by itself. I want to know, what does x equal? And you may be able to look at this right away and figure it out, and that's fine. But we want to walk through the steps, because as they get more complicated, it's going to be easier to solve when we know the steps. So in this case, I have my term or variable that I'm trying to solve for, the x. So in order to get the x by itself, I need to move or get rid of this 7. Right? This is the only thing that's on this left side that's stopping me from knowing what x equals. So if I want to move or get rid of this plus 7, how do I get rid of plus 7? So if I'm adding something, how do I cancel that out? How do I make that 0? How do I get rid of it? And it goes back to the opposite operations, right? I'm just going to write it down again. And the opposite operation of adding 7 is subtracting 7. So I'm going to minus 7 from the one side. But in order to keep things balanced or equal, I have to subtract 7 from the other side as well. So when I write this down, I get x. I'm not going to have anything because this will cancel out, because if I add 7 and take away 7, it cancels out. And I'm left with 39 minus 7. So I'm just writing out this long form. Then x equals 32. You don't have to show this part here, right? I'm just showing it in there to show the 39 minus 7 still exists, and then I simplified it. So that's where we know the 32 comes from. Again, if you're comfortable, you can go right from the top, show that you're subtracting 7, and go right to your answer. In the next example, I have 5x equals 125, or 125. So here, again, I need to get x by itself, right? I need to know, okay, what operation is going on? How do I cancel out whatever's happening here? And what's happening here is, this is multiplying. When we see a coefficient or a number and a variable, or a number and a letter, and there's no sign in between, that means we're multiplying. So how do we cancel out multiplying? Well, to cancel out multiplying, we have to divide. So I'm just going to rewrite this a little bit lower. So 5x equals 125. To cancel out the multiplying by 5, I'm going to do the opposite operation, which is divide by 5. I need to balance it out, so I need to do the same thing to the other side. It'll cancel out on the one side, and I'm left with x equals 125 divided by 5, which is 25. So that is my final answer. I've solved for what x equals. If I want to check my answer, the way I can check my answer, I'm going to sub x equals 25 back into the equation. So I have 5, instead of x, I'm going to do 25 equals 125. 125 equals 125. So this works, because 125 does equal 125, so this is a correct answer. My next example, here I have 2x plus 7 equals 11. So I need to, again, solve for my x value. I need to figure out what does this x value equal. Right? But now there are multiple things here. Right? Again, I'm solving. I want to know what does x equal. But there are multiple things here. So how do I know what to start with first? And again, this is where opposite operations come into play. So it comes into play in multiple situations. So opposite operations, and I start with S, A, M, D, E, B, or SAMDEB, right? So I'm looking for first, the first thing I'm looking for is subtraction or addition. And I do have some addition here. I have the plus 7. So if I want to cancel out the plus 7, I have to minus 7 from the one side. When I do that, they cancel out, and I'm left with 2x. Now, again, remember, we have to keep things balanced. So in order to keep things balanced, because I subtracted the left side of the equation by 7, I have to subtract the other side of the equation by 7. So 11 minus 7 is 4. Now, the next step, I need to cancel out the 2. So to cancel out multiplying by 2, because again, remember, between the number and the letter, if we don't see any sign, it's multiplying, I need to divide by 2. To keep things balanced, I need to divide the other side by 2. So the one side, they'll cancel out. 2 times 2. What if I multiply by 2 and then divide by 2? They cancel out. And x equals 4 divided by 2, which is 2. So again, when we have more than one operation going on, we have to use opposite operations to figure out where to start. In this case, we're starting with anything that's subtracted or added to our term or our variable. If I look at the next example, negative 15 equals 2y plus 10. So now things are on the different side of the equation, but the steps are going to remain the same. Right? I'm still going to work with opposite operations. So I'm still dealing with S, A, M, D, E, B. Let me make that last one a lowercase. Right? So I have multiple operations going on. There's multiple terms here, multiple things to worry about. So I'm going to start with my subtraction or addition, and I do see some subtraction or addition happening, right? I see a plus 10 that I want to get rid of. So in order to get rid of plus 10, I have to minus 10. And the reason that we're not worried about the minus 15 on the other side is because it's already on the opposite or the other side of the equal sign. So if it's already on the other side of the equal sign away from my letter or my variable, I don't need to worry about it. I don't need to worry about moving it. It's already far enough away. So I've minus 10 on the one side. I also have to minus 10 on the other side to balance things out. It'll cancel out on one side, so I'm left with 2y, and negative 15 divided, or negative 15 minus 10, I get minus 25. And again, I have one more operation. In order to get rid of the 2, I need to divide both sides by 2. Right? Again, the operation that we're seeing between 2y is multiplying. To cancel it out, I need to divide or do the opposite. It cancels out on one side, and I can't really simplify that any further. Right? I couldn't get a decimal, but I'll leave it as a fraction. So I get negative 25 divided by 2 equals y. And that is my final answer. Moving on, again, another example, slightly different, but again, the idea is still the same. So I have m over 3 equals 22. And again, when it's a fraction, remember what that line means. It means division or divide. So if I want to cancel out dividing, the opposite of dividing is multiplying. So I'll rewrite this. So m over 3 equals 22. To cancel out the division, I'm going to multiply by 3. And to keep things balanced, I'm going to do the same thing to the other side. Multiply by 3. On the one side, it'll cancel out. And I'm left with m equals 22 times 3, which is 66. So that means m is equal to 66. And lastly, negative 2 equals m over 3 plus 6. Again, I have multiple things going on here. All right, I want to get m by itself. So what I'm going to do, again, to figure out where I start, reverse BEDMAS. And the first things you're looking for always is that subtraction or addition. Is there anything that's being added or subtracted from my variable that I need to cancel out? In this case, there is. I see a plus 6. So in order to cancel out plus 6, I need to minus 6. And I'm also going to minus 6 from the other side to keep things balanced. It'll cancel out on the one side, or basically become 0. So I'm left with m over 3 is equal to, and then I have negative 2 minus 6, so I have negative 8. Now we have a question that's very similar to the last one. Because I'm dividing m by 3, I need to multiply by 3 to cancel that out, or turn it to 0, or 1. And on the other side, I'm going to multiply by 3 as well to keep things balanced. Again, one side will cancel out. And I have negative 8 times 3, so I get negative 24 equals m. So even if m is on the left side, that's fine as well. All right, because you could just switch them. M equals negative 24 is the same thing as negative 24 equals m. So again, the key things here, right, is do the opposite operation to cancel things out, right? And the goal is to get the variable or the letter by itself. In order to do that, you need to cancel things out by doing the opposite operation. It's quite simple when you only have one step, right? Like if we look at the first example, the second example, and the fifth example down here. So if I 1, 2, 3, 4, 5, right? 1, 2, and 5 are examples of one-step equations because there's only one thing we need to do to get our answer. 3, 4, and 6 are what we call two-step equations because there are two steps that we need to do in order to solve it and get an answer. And so when we have two steps or multiple steps, what we want to do is start with the subtraction or addition. See, what are we adding or subtracting to that variable? And then that is where you're going to start. That's what you're going to cancel out first, and then move on to whatever's left, which will most likely be multiplication or addition, right? And again, if you're stuck, just think opposite operations. You use opposite operations to figure out where you're going to start, and you use opposite operations to help you cancel out the numbers or the terms so that you can get the variable by itself.